unit heaters that we have some different solutions through Hazloc heaters. And that is a new line that we have brought on in the last few months. So we're really excited about this technology and everything that it can bring to the table, especially for your type of projects that you guys get involved with, especially in the wastewater world or in any kind of corrosive environments or industrial heavy duty and, explosion proof environments. So want to switch the screen, Chris? Just a little bit about myself. Those who don't know, I am involved in ASHRAE, West Michigan chapter, northern section. That's a picture of me catching a king salmon there a couple of years ago. So that is something that I advocate for ASHRAE and try to get to meetings when we do have meetings, obviously, or virtual meetings. I have been in the industry for over 25 years doing design work all over the board as far as the specific products and solutions. Heat trace obviously is one of the key ones that we've done several projects with Fishbeck on. In the recent years, in the last 10 years, I've been working in the outside role, more or less doing sales engineering and field technical services. And that's where I've gotten more face-to-face to meet everybody out in the field and meet you guys in your offices. So, which has been great. I've really enjoyed that. And I miss not being able to see everybody. Go ahead and do the next slide. So Dale Prentice Company, just so you know, we are a Michigan-based company. And we are a exclusive supplier for industrial and commercial products where we solve problems safely and effectively. A lot of our products really revolve around safety. And I'll talk a little bit about that in terms of what types of products we offer if you're not aware. Go ahead and next slide. So these are some of the solutions that you guys may or may not know we get involved with. Electric heat tracing, as I mentioned, for pipe. Is a big part of what we do. We also do some specialty things like leak detection, whether it's a water application or if it's a oil. If you have, say, a generator and you need to, contaminate or contain an oil spill area, we can do that type of leak detection, as well as other chemical contaminants. Gas detection, same thing. We offer a slew of types of gases that we can detect an alarm for. And then snow and ice, which we know very well in Michigan. I'm sad to say that the S word is still going to be around. It looks like later tonight I'm going to get snow at my house. But hopefully we're out of the main window of snow and ice for the season. Where we do it in buildings, you guys are probably familiar with in gutters and on roofs. We do a metal panel, which I think I've come into your office before and done a little spiel on, but it is something fairly new where we can contain or cover it up in metal panels if that's appropriate. So architects tend to really love that option as well. And then the surface snow melting, where we can put heat in the slab and the concrete and have a nice sidewalk walking path or driveway or what have you. So if you want to flip to the next screen. Then some of our other solutions that really revolve more in the industrial sector, especially in like processed chemical and oil and gas, are things like our overpressure protection, where we do relief valves, we do rupture discs, the Fike rupture discs, as well as the explosion protection systems. So I don't know if you guys get involved with dust collector systems or anything like that, where you have a potential where that you could have an explosion situation. And we have both an isolation and suppression type technology that we offer and assist with the engineering on as well. So if you have any projects like that, just give me a call and we can talk more on what the next steps might be to get the engineers involved. And then, of course, valve actuation and controls, and then the valves, which we do a multitude of valves, whether they're 2 ways, 3 ways, all different types of valves we get involved with. That is the mechanical side, more or less. And then if you want to flip the screen. And then today, of course, we're going to be hitting on all of the Hazloc heaters, which we'll go into on the solutions and the different environments they're good for, and some of the key things, the key takeaways for you as engineers to understand, you know, when you're looking at a project and specifying and what you're looking for on the quality piece of it. So without further ado, Chris Turnbull is the regional manager for Hazloc Heaters, and I will let him give you his bio and introductory. And I appreciate your time today, and hopefully you guys have some questions near the end and we can help answer those.
Thanks, Melissa. If you have any problem hearing me, please just shout out and say so. I'll do my best to speak up or whatever. As Melissa pointed out, I'm going to go pretty quickly through this because getting this done in an hour is more of a challenge than you would understand at this point. We do have a lot of features with our products that we're very proud of, and we tend to dwell on them sometimes, but we're going to make sure that you hit the high points today and you get the information that you need to understand Hazloc Heaters as a company and as our products. So we've been around since 2004. It was started by two gentlemen who used to work for a company by the name of Roughneck. Roughneck no longer exists. It is a brand name, but the company itself is gone. They were purchased by another company, which has since been purchased by another company. And one of the things that Clinton Lewis, who was the president of Roughneck, and Darren Ochosky, who was a vice president of Roughneck, decided at the time was that Roughneck had a 90 to 95% market share in Canada, and there was a market for a good quality alternative. And so they started Hazloc Heaters. We've been going now since 2005, and as you can see, we've added new products throughout the years. Even this year, we've added we are adding several new products, and I'll talk about those a little bit later. These are some of the customers that we do business with. They range the gambit from drilling rig companies to companies that are in the oil sands, shipping and marine companies. Torm right now is one of our biggest customers. They have, on average, they order about 6 heaters a month to put in their ships. Pullet Biorefinery, this is another customer that is coming on board and has been buying a lot of heaters lately. They've got over 2,000 locations around North America. And 2,000 locations around North America. And they are, buying a lot of heaters these days. So I'll start right up front by saying, why Hazloc Heaters? Hazloc Heaters are manufactured to the highest quality standards. Our company is ISO 9001 2015 certified. Our certifications, Hazloc Heaters have the most certification of all heater manufacturers. We have heaters to fit virtually any application internationally. So the C, CSA, US, and UL are both North American. ATEX, IECX, that covers most of the world. EACX covers Russia. CRN is a Canadian standard that is used worldwide, actually, amazingly enough, on hydronic and steam heaters. All of our X-Proof heaters are also compliant with AMCA 99-10, which is type B for spark resistant fan shroud. And I'll explain that a little bit later. We're the only company in the world that does that. Safety features not found on competitive heaters include things like 2 high limit reset switches, an automatic and a manual. There are companies out there that offer automatic or 2 automatics, but the problem with automatic high limit switches is they're prone to failure in a closed position, and they could cause problems. We have a fail-safe pressure relief device, which nobody else in the industry uses. And again, we have that spark resistant fan shroud that nobody else has. We have a limited product scope. We realize this. It is expanding as we go on. But this allows Hazloc to specialize on the products that we do manufacture. We don't want to throw a product out in the field that is anything less than what we would consider the best in the market. Dependability. Our company tagline is save heat when you need it. Value for the dollar. This is a combination of upfront costs, which are very competitive, regular maintenance costs, and life cycle operation costs. And all of those things combined give Hazloc the best value for the dollar. Comfort. Hazloc has the best heat rise, and I will talk about that in the presentation across our entire product line of X-Proof electric heaters. And service. Our service, and I think Melissa and a lot of our reps will tell you, our service as far as quoting and heater sizing and other technical services is exceptional and very timely. You will probably, if we hear from you and you ask for a quote, chances are you'll have it within 4 hours. Typically it's within an hour, but it's not 2 weeks later like some of our competitors do. We have in-house production. We have 2 robotic core welding machines. We have 4 welders, manual welders. We have core pressure test center. We have a wood shop for our heater crates, and we have an in-house paint booth that we paint all our cores. The wood shop, we have a wood shop because we do sell internationally, and internationally, if you sell if your heater is sent in a crate to other areas of the world, the lumber has to meet certain specifications. And so we just decided that we're going to do that for all of our heaters and all of our heater crates. And so we build our own heater crates. We don't count on somebody else doing it. Here's some images of our PDFs, our product guides, our brochures. The product in the upper left-hand corner here, this is called a steam rig heater. It is just what it says. It's a rig heater. It's designed for working with steam in a drilling rig. It has a few limitations that the other ones don't, in that it has 150 psi maximum pressure. Why 150? Well, it's because of the design of the header. The header is designed to be able to be frozen once or twice, and then that way the heater doesn't get damaged. And drilling rigs are prone to doing that every once in a while. These 2 heaters here, the HUH and the HHP, are our hydronic heaters, so they'll run on steam or they'll run on glycol, water, hot air, whatever you want to put through them. As long as it's a non-lethal fluid, you can run it through it. The HHP2 is typically we call it our high performance heater. Typically with steam and things like that, I can run if I'm running a 24-inch HUH2 with steam, I can typically run the next size down with the HHP, which means this product here is about the same cost as this one, but has better performance in the smaller size. So it saves room, it saves costs, it just does everything much better. The XCU is the electric heater that's certified for North America. I'll talk about that one first. And the AAU one, I won't talk about that today, but it is virtually the same, just has different connections in that. And it is certified for international use anywhere in the world. So one thing to know is that if you go to the Hazloc Heaters website, all of our product brochures, owner's manuals, approval drawings, and even items like step drawings are available to download from our website. The XEU is a North American heater. It's CSA US approved. That means it is UL approved. Okay. We say it is UL approved because by virtue of putting the CSA US approval, the US part of it means that it was tested to UL standards to ensure that it is capable of going to the United States. It's available in sizes 3 to 35 kilowatt. The outside of it, in a lot of ways, looks similar to our competitors' products. We're told it's actually the nicest looking product on the market. Many people like the bright yellow. It's called safety yellow. The reason we use safety yellow is because the heaters go in places where there's not a lot of light sometimes, so you need to be able to find them if you're looking for them. And a lot of places are low overhead clearance. So people really appreciate these in drilling rigs and stuff like that, where there's low overhead clearance, because they can see them and they're not banging their heads constantly on them. How do the electric heaters work? Well, the electric heaters, there's in the bottom here, there's 3 elements. The elements are wired together. Those elements are provided power from the top here, from the control box. Once they're energized, the elements start to heat up. They're immersed in a fluid. That fluid will heat up. As it heats up, it will turn to a boiling point. Once it gets to the boiling point, the steam will start to rise in the core. It's very important that you do certain things with these heaters. Number one, the elements have to be in the fluid in order to be heating, to be actually providing and converting that fluid into steam. So they have to have the elements in the fluid. You have to have a good quality glycol in here, or you will have the glycol will break down over time and it won't function properly, and you will have failure in your heater. The other thing you need to have is a good vacuum on the core, and I'll talk about that in a little bit. And the final thing you need to have on here is you have to have a fail-safe pressure relief device. That is very important, because you're heating a fluid down here. It's turning to steam. You're filling the core with steam. That steam has a pressure, and this safety device at the top here must be able to relieve that pressure at a moment's notice if it should be required. Here's what it looks like from the back. You see the 3 elements in here. They're bound together. There's 2 high limits. There's an auto high limit, which is in thermal well, and then there's a manual high limit, which is a negative thermal well on the outside, which is on the outside. And I'll show you that again too. This is what it looks like with a cutaway. From the side, these are the 3 elements in here. And so you know, this particular element or heater is a 600 volt. So it'll be a 3-phase, and it's 7.5 kilowatts. The elements are positioned in such a way that this is one element, this is an element, and this is an element. So they're connected so that they all raise heat at the same time. These 2 things here that you're looking at, this is the automatic high limit that we talked about earlier. The auto high limit, again, is not guaranteed to fail in an open circuit. It could fail in a closed circuit. Even though we use the highest quality one we can, it's, you know, 90, I think it's like 94 to 95% guaranteed it'll fail in an open circuit. We still don't trust it, so we actually have a manual reset switch on it. This is like the pop-up on a Butterball turkey. If this unit down here, if the high limit fails, and it's set for about 143 degrees Celsius, if it gets above 143 degrees Celsius and happens to hit, say, 149 degrees Celsius, well, that's the cutoff for the manual reset. The manual reset, this button on the back will pop up, and that will kill the power to the elements and will shut the unit down. Again, it's a safety feature that not all of our competitors offer, and those that do, some of them offer them as an add-on, so you actually have to pay for it if you want it. All the housings on the unit have a threaded cap with an O-ring. The threaded cap is part of the explosion-proof designation for the heater. That cap must go on a full 5 rotations, minimum of 5 rotations. And then we put the O-ring in there just to make sure it limits the moisture and dust ingress. It doesn't really affect the explosion-proof part of the product. This is our Canadian competitor's heater. This is a website picture. One of the things that we do that a lot of our competitors don't do is we plate our bus bars to make sure they're H2S safe. If you're going into places like wastewater treatment plants, oil and gas facilities, you know, any processing facility where, you know, there's a possibility of having H2S, you should never have copper or brass in those elements because they're yellow metals, and H2S will eat away at those very quickly. Quite often, in less than a year, they'll eat away at yellow metals. So we tin plate our copper bus bars, every single one of them. When they come to us, they're brass. We turn around, we send them out to another company, and they tin plate them for us, and then they send them back to us, and that's what we use. This is our competitor's heater. This is their website picture. We were selling the fact that we were tin plating our bus bars, and so they posted a picture on their website saying, hey, yeah, this is what we have this is what our heaters look like. But in fact, when you order the heater, this is actually what you get. You actually get copper bus bars, not plated in tin, which are susceptible to H2S and corrosion under certain circumstances. You'll also notice that the automatic high limit reset switch is the only reset switch that they have in here. There is no manual. You have to order the manual if you want it. And most people will not order it. They just take the high limit. The other thing I'm going to point out to you is look at how low our elements sit in our housing. This is actually if you draw a line across the middle, I'll go right through these two bolts here. So the elements are actually sitting in the bottom of the housing with the fluid level approximately to this line here. With our competitor's product, you'll notice that the middle isn't quite the middle. If you look at the middle of the heater, it actually cuts across, and the elements actually sit pretty high. So when that fluid goes through the phase change of changing from a liquid to a gas, the fluid level is actually going to go down. It'll actually drop down. And in some cases, it may drop down below the elements, which will cause problems over time with the elements burning out and reducing the life of them. Here's a picture of the elements in their housing. You'll notice again, ours are offset to the bottom, just to make sure that they're always in fluid. You'll also notice they're a much finer one, and they have more space between them so that the liquid can get in there and mix. I talked about heat rise or higher temperature rise earlier, and that our heaters have a better heat rise than our competitors. Well, temperature rise depends on two parameters. One is the kilowatts and one is the CFM. With Hazloc heaters, for every kilowatt size, except the 35 kilowatt on the Hazloc heaters, there is a different pitch of fan blade. This provides the optimum airflow to achieve the desired temperature rise. This is data right out of our respective product brochures. If you look here, you'll notice our CFM jumps every single heater. And that's because every single heater, the fan blade is designed to maximize the heat rise. Okay, and I'll show you this again on the next chart. Whereas our competitors, where we use 8 fan blades, they only use 4. And what you notice right away is that the CFM is pretty high in some of them. I mean, 3600 CFM is pretty high, but it reflects in the heat rise of the product. So if I show you a chart here, this shows the heat rise. This is the Hazloc product. This is a Roughneck product. This is a Chromalox, and this is Indico. We'll look at the heater in the middle, the 15 kilowatt. Heat rise on a heater is the amount of temperature above ambient. So if you have a heater that's in an environment that is 0 degrees Fahrenheit, what is the heat going to feel like coming out of that heater? Well, at 15 kilowatt, if you have a heater that's 0 degree and the air outside is 0 degrees Fahrenheit, and that heater is working inside the building, the air coming out of that heater is going to be 40.6 degrees Fahrenheit. So that's above freezing. If you look at a Roughneck, their heater is going to be 27.1 degrees. Chromalox, 31 degrees. Indico, 27 degrees. All 3 of these are blowing air, but the air that they're blowing is below freezing because they maximized the CFM, not the temperature rise, whereas Hazloc maximized the temperature rise on each of these individual heaters. You look here at the 27.1 for the roughneck, and then the 36.1 for the 20 kilowatt. They maximize the heat rise, or the CFM, in that for the 20 kilowatt, and that's why it's affecting the 15 kilowatt negatively. So that gives us a 46.7 degree, 46.6 degree advantage over our roughneck, 20.9 over Chromalox, and 41.2 over Indico on the explosion proof heaters. Talk about temperature rise and the importance of a vacuum on the core. Here's a roughneck heater that's been turned on for 45 minutes. And here's a Hazloc heater that's on 15 minutes. What you're seeing here is the difference between a core with a vacuum on it and a core with an out of vacuum on it. We know the process that our competitor uses to put a vacuum on their cores, and it's inconsistent. I have gone, when I started with the Hazloc and I was in the field, I would go to oil and gas sites, and more times than I can count, people would say, I'd say, do you have roughneck heaters on site? And the guy would say, yeah, those are the ones that blow cold air. What they're referring to is this. The heater will be blowing warm air down here, but the top is what we call dead air. In steam systems, you have to purge all the ordinary air out of the system in order to maximize the heat rise, or the temperature rise, or the steam in the system. So when they're building a system, they'll actually go around and they'll open up every port in the building. They will turn on the steam. Steam will be blowing out of every port. And then from the furthest point out back to the boiler, they'll go around and they'll start turning it off so that it's sealed. And once it's sealed, then they'll shut down the boiler. That will ensure that there's a vacuum on the system. And that's what we do. We put a vacuum on the core so that when the elements start to heat up the fluid and the steam starts to rise, it can rise all the way to the top without this dead air stopping it. This is a Chromalox heater on 15 minutes, and our heater on 15 minutes. When we look at our advantages over our competitors, we have the plated bus bars, we have the backup manual reset, we have the elements always in fluid, we have high temperature sealant on our units, we have O-ring on the control box, we have a balanced cabinet, which means front to back the cabinet is balanced so that it hangs straight without having to use shims and stuff like that. And we have an automatic high limit reset that is next generation. I spoke earlier about the importance of a high quality, fail-proof, fail-safe overpressure device. We use a rupture disc, and we don't use just any rupture disc. We use a rupture disc from the people that invented it at BS&B. This rupture disc is 100% 316 stainless steel. Each one of these things costs us about 55 to 60 bucks each. We do it because it's the right thing to do. We did have pressure relief valves on our cores for about 6 or 7 years. Our president, Mr. Lewis at the time, challenged engineering. We had a couple of them that started to leak. I think it was like 6 out of about 12,000 heaters. And he challenged the engineering to come up with a way to eliminate leaking overpressure devices. This is what they came up with. The rupture disc will not leak under normal operating pressure, which is between 5 and 30 psi. Ours are set for 150 psi. Each one of them is factory tested with helium, because helium is 10 to the minus 8th smaller than regular air. So you will notice any holes or any leaking right away. They're designed for vapor and high heat applications, and they're threaded with permanent Loctite. Each one of the burst discs is fully traceable. It has a batch code, it has a set point, and it has pressure testing data on it. In this case, this one says it was pressure tested to 147.5 psi at 160 degrees Celsius. Therefore, they can say it will approximate approximately burst at about 150 psi, and I'll show you on the next slide why they say that. And there's a batch code on every one, so we can trace it back to the day, the place, the line it was manufactured. Again, 100% fail-safe, designed to stay fully intact, like a pop can lid, only in reverse. They actually laser etch the each unit so that when this thing pops, or should this thing pop, it will pop out very much like this. It is a straight line evacuation of the pressure, so it's much quicker and it's also much safer. But again, you don't have any shrapnel flying around the building. Here's an article from PTQ Engineering Magazine in 2018 where it talks about the better response to sudden pressure, isolation, and the fact that safety valves tend to be less tight after initial triggering and usually require removal and recertification. Well, with a rupture disc, once it's gone, it's gone. You have to send it back and get it fixed. This is what our competitors used to use. This is the roughneck heaters. They used to use this particular valve, and what they found, there's literally thousands out there, many thousands out there in the field. They use this on what they call their FX4 and FX5 heaters up until about 2016, 2017. You can see in this one, it's already got signs of scale buildup inside here. This is either inferior glycol or dissimilar metals or something. We just don't know what it is. Nobody's ever been able to find out or come up with an answer. Over time, this has proven to be very dangerous. Here's one that failed. This one was in 2019. This was reported by Energy Safety Canada. It actually was one of our customers who had the heater on one of their rigs. It was Neighbor's drilling rig in Canada. And this was an older rig, and they hadn't changed the heater out. This heater is actually in a box. It was actually in a change room mounted on the floor. And when it blew up, there was a steel bench in the change room that was about 2 feet from it, and it blew the steel bench. It had 8 metal bolts holding it to the ground. It actually blew the metal bench through the door of the drilling rig, and the guys had been in the room just about a minute and a half before this thing went off. So you can imagine what the potential for serious injury could have been. Here's the safety alert. Energy Safety Canada does monitor any reported instances, and so you can go to their website and look up these things. They post a cause and a contributive factor and then corrective actions and stuff like that. The funny thing is, the corrective action in this case is the customer didn't do regular maintenance, so it's his fault. Today they use a different pressure relief device. It's non-branded, it's non-traceable. It's even though they say it's 100 psi, there's no operating temperature, pressure available or anything. There's no design data whatsoever. We've had many engineering companies go to Roughneck and say, hey, we'd like to get a copy of this, and they just can't get it. There's just nothing out there for it. We believe it's something they put together in the shop, and fine and dandy, that's what they do. The cost of this is probably $4 or $5 when you include all the parts that are in it. Here's the parts that are in it. The first thing you notice about it is that in order for it to operate, it actually has to do a 90-degree turn. It's a very small port, and any venting fluid or steam has to come out and make a 90-degree turn. Then there's the potential, multiple potential points of failure. This is a neoprene or rubber disc. This is a stainless steel or aluminum cup, spring steel, and then carbon steel. So you've got dissimilar metals. You've got multiple points. If this, like we've seen with some people, they say, well, this part here could get pinched and this could break down, and this spring steel could break down. It could corrode in contact with the carbon steel. It could rust and things like that. Things have happened. This was a bulletin that was put out by Thermon Heating Systems, who is the company that is the parent company for Roughneck, regarding their XL4, FX, and FX5 heaters. And this is regarding this particular valve. This was issued, and we believe it only went to the people in Canada, companies in Canada and customers in Canada. We don't know of any US customers that got it, but we do know in Canada they did. The part that really threw us off was if you're a company like Thermon Heating Systems or Roughneck, and you have to put out a document like this that says the result in catastrophic rupture and bursting of the heater core, potentially leading to death, personal injury, or property damage. I can't say I'd be that thrilled if I was working for the company to be putting something like that out. That particular brochure stemmed from this incident in Redwater, Alberta. A worker went into the facility, and this is what he walked into. This was the week of February 17th, 2020. It was a heater that was less than 1 year old. This is what he found. The only thing that really kept the heater located in this particular area was this piece of Tech 90 cable that was holding it together, that was holding it in place. Other than that, it was blowing all over the place. And as you can see from the damage, it went up through the roof and through the wall and damaged some other equipment inside the room. This is not the first one. They've had several instances, but this was one of the most recent and one of the worst ones. This is Energy Safety Canada. They issue safety alerts. These were ones that were issued prior to 2011. They've since designed their system so it only goes back to 2011. You can ask them for more that go back, and it's designed to only go back 10 years now. Standard operating temperature limitations. Roughneck heaters operate -20 to +40. They use a proprietary motor that is only available from them. Hazloc heaters, we use Marathon motors because Marathon motors are available anywhere in North America. You can go down to your local store and somebody's going to have a Marathon motor, explosion-proof motor, and you'll be able to get one pretty quick. We don't want our customers to be waiting for us to ship them a new heater or a new heater motor from our factory because it's a proprietary thing. We want you to be able to get it whenever you need it. We also have to specify in uncertain terms that our operating temperatures are -40 to +40. The reason we have to do that is because this is what they call outside of the norm. The norm is considered -20 Celsius to +40. We are outside the norm. We do that because we know where our heaters are going to be. We're in Canada. I mean, hell, where I'm in Calgary, it gets down to -40. And the wind chills, I mean, this winter, there was days it was down to -60. So, I mean, it's not unusual to have that kind of weather. So we know what our heaters need to stand up to, and we build them to do that, just that. The control box, very much like the other box, the element housing, has a threaded cap with an O-ring. We use NPT seals in the top. We used to use a black plastic plug in this side. Problem was, because this is where the line is supposed to be coming in, problem was guys in the field would get there and they'd go, oh, well, I only got 3/4 inch NPT, so I'll just run it in here. And they'd leave that black plastic one in there, and it wasn't ever meant to be left in. It was meant to go out, and it would make the heater literally not explosion proof. So we had to put NPTs in both sides, and so that, you know, we could be, I guess you would call it better idiot proof when it comes to installing the heaters. Line is on the same side as the entry box with our competitors. You have to go all the way around. The line comes in here, but it has to go all the way around this side in order to go into the contactor. We also have 24-volt controls, which several of our competitors do not. They only offer 120 volt as an option, and we offer 24 or 120. Remembering that is only operating for that control power is really only used to operate. It's either going to a 24-volt control panel, or it's going to a thermostat, and T-stats don't need to be anything more than a 24-volt or 120-volt at most. We have an easy off fan blade replacement feature, which is handy should you have to replace a motor. We have a fan guard that is, want of a different term, the best in the industry. We've had many people tell us, you know, my staff member put their hand around back to check the something, and their finger went into the fan blade and nipped the glove or nipped the finger or whatever. We've even seen instances like this where the actual fan came through the guard. The guy was banging his hand on the back of the heater trying to get snow off his glove, and the fan blade came through and nipped his hand. All of our porting and conduit is has pressure piling shear grooves, so that there's no possibility of any explosion within the unit backfiring and causing any more damage than it has to. We do little things like deburr the louvers. We have dimples on the side just so it doesn't scratch. I spoke about the AMCA B standards. We are the only company in the world that goes the extra step of lining all of our fan shrouds with aluminum, so there's no possibility of spark. Apparently, if a fan blade, an aluminum fan blade, and the carbon steel on the housing, the casing, if the casing was to get scratched and the fan blade was to rub against rust that would develop in there, there could be a spark. And this was brought up by IECEX, an international mechanical directive. And we just said, if we're going to do it for one heater, we're going to do it for all. So we just do it for all of our heaters, regardless of the size. This is a 36-inch heater, and this is a 12-inch heater. They all get the same treatment. Our cabinet tops are stiffened so that when there's vibration in a building, which there tends to be sometimes, you will have no effect on the heater. Here's a heater that where the weaker cabinet actually tore and it came apart, and it was on the verge of falling. One thing people mistake quite often is that explosion-proof enclosures are not waterproof. Explosion-proof for NEMA 7 and 9, waterproof for 4 and 4X. The two don't mix. We do everything we can to make sure people know to keep the heaters dry, but lo and behold, it not always happens. These particular heaters here, these were just instances where somebody left the plug out of the top, didn't use proper glands or wire, and the water ran down the wire into the control box and then down into the element housing. And this is what it looks like when you open them up. If we get a heater back with a suspect and we suspect that moisture got into it, we will videotape every heater that we open up as we open it up, because it will show. This particular one here, customer said, hey, it keeps shorting out. We can't figure out why. You know, no, it hasn't been outside, no moisture's got into it and all this kind of stuff. And when we opened it up, this was actually what it looked like. Now you can see the 24010 right here. And if I go back here, you can see the 24010 right there. That's the exact same heater. When we opened it up, it just had a big chunk of ice in there. And when we got down into the story, found out that they bought it in October, didn't install it until February. In the meantime, it had been outdoors a couple of times, and you know, it had got moisture in it. Again, we label everything we can. We label the crate, we label the heater, keep dry. We put the NPT plugs in there so they keep dry. We put the O-rings on, again, to try and keep everything dry. Explosion-proof accessories for our heaters. This is the new BTX1-N-B. This is a bimetal explosion-proof thermostat. This particular one is good for H2, Group 2 being H2. It's the first and only one on the market today. Extremely accurate. It's plus or minus 1 degree Celsius. We have to say 1 degree Celsius because we can't say 0.5 in this case, this one is 0.74 degrees Celsius. So we have to say plus or minus 1 degree Celsius. It's lockout capable and it's suitable for hydrogen now. If you buy a heater from us and you don't order a thermostat on it, what you get is you get actually a blank box on it. Every heater comes, this blank box that you see that will be on the heater will actually be pre-wired for a thermostat. So if somebody decides later on, well, I didn't buy a thermostat, but I need a thermostat and I don't want to put a wall one on. If they want to put one on the heater, they can do it themselves. Everything is pre-wired, pre-set up. All they have to do is buy this, take the face off it, put it on the heater, and it's done. Okay, so the blank box is on every heater. The nice thing about the blank box too is if you buy a heater with one built into it and you want to move that thermostat off the heater and onto the wall, you buy a blank box and you can mount it on the wall. We're the only company that has a fully electronic explosion-proof room thermostat. This particular thermostat only works on 24-volt controls. It is very unique. If you have areas where there's a lot of moisture or vibration, we highly recommend this product. Again, plus or minus 1 degree Celsius, because we can't say 0.52 degrees Celsius. It is completely vibration resistant. We have customers that have bought this product simply because of the vibration resistance. It has no contact points in the control box inside. This is the electronics for it. These are 2 magnets on here. These magnets are telling the electronics what to do and how to do it. I have a gentleman who has a facility, shell facility down by Waterton National Park in Alberta here. One of the most beautiful places on earth. But the wind blows 140 kilometers an hour, 70 miles an hour, 70 to 80 miles an hour, 100 days a year. And he was having problems with the walls of the building moving and the thermostats weren't keeping set point. So I sold him a couple of these. He has yet to, he phones me once a year and just says, hey, Chris, that thermostat's still working. And that's about 8 years ago that he did that. This is our competitor's heater. The one thing I will point out is the temperature differential. Where we're plus or minus 1 degree Celsius or 1.8 degrees Fahrenheit, they're 6.5 degrees Fahrenheit. So if you want to keep something at 32 degrees, say you want to keep something at 34 degrees, 36 degrees Fahrenheit, okay? With a differential of 6.5 degrees Fahrenheit, there's no guarantee that that thermostat is going to keep it above freezing, okay? Because 36 minus 6.5 is 29.5, and that's just going to that's below freezing, and that's not going to be capable of keeping it where you want it to be. So we've had a lot of customers that have come to us because of this factor. We have a disconnect switch. The disconnect switch can be built in or it can be remote. It has a lot of inputs and outputs. When you look at our competitor's product versus our product, lockouts accept only small locks. There's limited workspace inside the enclosure, and it's a very flimsy handle. It's only got 2 number 8 screws holding that handle on, whereas ours has some, I think they're 1/4 inch, 8/32 4 bolts that hold the face and that handle on with ours. Our handle also has a guaranteed lockout. You can use small locks, large locks, or even cables to lock it out. And that we're told by the industry is much safer, and they really, really appreciate that. Here's a customer that had a low overhead clearance problem. They really appreciate the fact that they could come in from the bottom into the disconnect. So they did that. Here's another customer, the Suncor Voyager package up in Fort McMurray on the oil sands. They mandated that in the Voyager package, every piece of equipment that was running power had to have a Hazloc heater disconnect switch on it, because it was the one that they deemed most reliable and safest. We have herbicide coatings for harsh environments, like in wastewater treatment plants and places like that. We sell a lot of these into wastewater treatment plants with the herbicide coating. Again, it tends to be much less money and lasts longer than stainless steel and stuff like that. All of our heaters are designed to fit into our competitors' mounting brackets. So if we've got especially roughneck heaters, if you've got a customer who's got roughneck heater and he wants to put in a Hazloc heater, he doesn't necessarily have to change the mounting bracket. He can just put the same size and fan rating into that mounting bracket. We test our cores. This is a test where our core was tested at 2,900 PSI. We stopped at 2,900 because it only went up to 3,000. Judging by the damage that was caused by some of our competitors' cores, I guess you could say we're kind of glad it's that way. Let's talk quickly about the hydronic heaters. Hydronic heaters are used for, as I said, glycol, steam, and other fluids that you might want to put through it. We meet ABSA and CRN standards. They can be verified. The CRN is listed on the front. The 2C means the 2 is Alberta, BC is 1, we're 2. C means that it's certified across Canada. The cores are pressure vessel quality steel. Not all of our competitors use pressure vessel quality steel. The HHP2 core, the headers are 40% thicker. Therefore, we offer a much better warranty. They're available in single pass or multi-pass. These cores are actually interchangeable with some of our competitors' heaters. And we do have some customers who have done that in the past. We don't like doing it because then we've got our core making our competitors' heater look better. These heaters can be used as coolers for cooling process fluids. If you want to do something like that, we've got a document that you can fill out, and we will help you with that sizing. We've got an engineering company, or engineering people that work with ACOL, and they can come up with that information that you need. What does a single pass core look like? Well, a single pass, you've got steam coming in the top, and this is where you would only use steam and you would only use steam in a single pass, and you would never use glycol in a single pass if you don't have to, unless it's really slow. Steam goes in and comes out the bottom. The idea of this is that when the steam comes in, any condensate that gets in there will come out with the steam at the bottom. Glycol, other hand, goes in the bottom, comes out the top. Again, you're forcing all the air out of this, so there's no air inside. It's just fluid, and it can be used better as a heater and as a cooler. There's a lot of people that use them. They buy them as coolers, but end up using them as both a cooler and a heater, just because of the function of the unit. So again, ideally, glycol goes in the bottom, comes out the top. We have 4 baffles in this, so this would be what we call a 5 pass. So 1, 2, 3, 4, 5 passes before it comes out. This would be used again either as a heater or as a cooler. The fan at the back is what blows off the air, or blows off the heat from the glycol, and that's what gives you your cooling effect. Very important that you use proper piping with any of these heaters. We provide that in our owner's manuals, and we expressly make sure people know that you should use proper piping. It makes a difference. Product testing, here's a core that was tested at 2,450 PSI. We test every single core in our facility, whether it's electric or hydronic. They all get tested at 420 PSI. The electrics only run between 5 and 30, and the pressure relief device is set for 150, but we test the core to 420 just because it's a standard number. And that testing is done on every single core to make sure there's no leaks. So the HHP2, we have a 50% longer warranty and a 40% longer core life. Again, that's because of the header steel being 40% thicker. The HHP2 can be used in a horizontal configuration or can be used in a vertical configuration with any of these options for airflow or discharge. Innovative, forward-thinking speed reducers are much more efficient than our roughneck competitive heater, which uses a tandem, which is what they call a tandem, which requires 2 motors on it. Speed reducers are up to 90% more efficient than belts and pulleys and are much quieter and have a longer lifespan. Here's a heater. Here's a heater that is running. Now I'm standing 3 feet in front of it.
From the unit, and I'm taking a video right now just to show how quiet it actually is.
So that's 3 feet in front of it. So I mean that's pretty quiet. It's actually, here's the one from the back. And again, this is just air getting sucked in. This is only the air movement. You're not really hearing anything from the unit itself. They're available with flanges. You can get a 4-bolt or 8-bolt HUH heater. It's very similar functions can be used with this heater. Design is a little bit different because of the fact that this can be used in rigs as well. It comes with female NPT fittings. Our competitor's product in the 36-inch size actually uses a belt and pulleys. So you've got the fan is up here, it's on a pulley system, and there's fan belts and motors. They use a winch, 1.5 horsepower motor. We use the speed reducer because it's 90% more efficient and much quieter, and it'll give it a longer lifespan and less chances of any issues of the when you're doing maintenance of throwing it off balance. I talked about the AMCA. The fan shroud is much thicker, much deeper with our product. That gives you more air across the core. We do have industrial grade unit heaters as well. These are what we call ordinary location. And this one here is an industrial washdown heater, which would be for corrosion environments. Go to our website. There's tools there. You can get owner's manuals, approval drawings, and you can download step drawings so you can actually put them into your engineered drawings. And coming this year, we will have a convector. They'll be the only convector on the market that gives you the option to have controls either on the right-hand side or the left-hand side. We do that because we have competitors. I'm going to say thank you and find out if there's any questions from anybody. I think we hit our hour, and please ask away.
Yeah, great job, Chris. Thanks. You did a lot of information in a very short window. So you did a great job.
It is. And if anybody wants more information, please pick up the phone, call Hazloc, call me, email, whatever. We are more than happy to give you the answers. Some people say there's no stupid questions. We want to answer every question you have, and we want you to be comfortable selling your product or putting the product in your buildings.
Hey, Chris, this is Mark. Regarding the noise issue, we did have a client that was complaining about the high noise of the Roughnecks. Is that because they use the same fan blade for multiple sizes, or why is it so hot? Okay,
that's right. That's exactly what it is. I mean, you saw back on that slide where the 25, 30, and 35 all run at 3600 CFM. Okay, whereas ours are 2500, 2400, and 3000, I think is what they are. That is a difference in sound. So that 25 kilowatt will actually sound a lot noisier than the 35 kilowatt. And so the same with the 15 and 20, the 15 versus the 20, and the 10 versus the 7.5, or the 7.5 versus the 10. The lower one is always going to sound noisier because it's got because the fan blade is working a higher CFM based on the larger heater. Does anyone else have any questions? I know it's a lot of information, guys and gals, you know, so please, I mean, like I said, if you have a question, please feel free to ask. And you've got my contact information here. You've got Melissa's contact information. Feel free to contact us, and we'll get you the answer that you need. And we are not above saying that we can't do something either. You know, we won't BS you and try and sell you a product that's not going to do the job for you. That's one thing that's important to know as well. I encourage you to go to our website, take a look around, see what's there, and play with any of the tools.
I was just going to say, is the website listed on here?
It's just www.hazlocheaters.com. If you go to Google or
Okay.
any of those places, we're usually the first one that comes up.
Yeah.
I think our marketing manager, he tends to keep that keep us right at the top of the list. But hazlocheaters.com is our website. You can find us there.
And so you mentioned, you know, because they do get involved quite a lot with wastewater treatment facilities that have, you know, gases and that are become a corrosive environment. You mentioned a coating, a special coating that they can specify in those kinds of environment.
Parasite.
And so is Harrisite something in the model number that needs to be called out, or does it just need to be spelled out when they, if they put it in the spec?
What you'll do is that you'll build your heater model code, and then once you've got your heater model code built, you'll just put behind it H1, H2, or H3. H1 means it's just the core, H2 means it's just the cabinet, and H3 means it's both the cabinet and the core.
With that special coating on it.
With that special coating. Now, the one thing that
Gotcha.
Hazloc does different than all of our competitors ship bare steel to get the Harrisite coating put on. Harrisite coating is put on by a couple of companies in North America. They do that, and I think it's down in Michigan, in your neck of the woods. But they do the process there. We don't necessarily do it in our facility, but a lot of our competitors ship bare steel down and get it Harrisite coated. What we do, and we found out early, was we actually have our epoxy coated yellow powder coated paint on there. We actually ship the heaters down with the epoxy yellow paint on, and we get the Harrisite put on over top. What that means is that you've got the Harrisite coating on it, providing protection, and the epoxy paint providing protection.
Gotcha. Okay, yeah, and I know that that's just real important when it comes to you know, environments that in particular, you know, at wastewater facilities or chemical facilities have a hard time. You know, the unit heaters tend to fall apart pretty quickly due to corrosion. So I just wanted to make sure, point that out. All right, well, hey, we've gone beyond our time. If there's no other questions, again, we appreciate your time today, and hopefully we're able to give you a little bit of ideas as to, you know, what we can help you with on different unit heater applications and solutions. Again, my name is Melissa, and I'm with the Dale Prentice Company. If you have any applications, projects, if you need specifications, drawings, anything of that nature, just give me a shout or send me an email. And Mark, I appreciate you helping facilitate getting this put together for us.
Thank you again to everybody for attending. And again, if you have any questions, give us a call.
Thank you.
Yeah. Have a wonderful day, everybody.
Thank you.